Good morning, my dear students. In the last few modules, we had discussed about the vectors and the way with which the vectors have to be worked, because physical quantities are vectors. So the knowledge of vectors and the mathematics of vectors was necessary before entering into the study of physics as such. Now we start discussing our physics from mechanics onwards here. In simple sentences, we talk about the motion of bodies and then the vectors involved with that, the calculations involved with those physical quantities in the vector knowledge also. We will be seeing it eventually. What is meant by motion at all? Motion means a body will move from its position to a different position. This is what we call as movement. When a body is at this point here, or sometime you find it somewhere else here, it means it has moved from here to there. If it moves along a straight line, we call it as rectilinear motion. If it moves along a curved line like that, then we call it as curvilinear motion. In any case, it is moving along one line. Sometimes it can be moving in 3 dimensions also. If you consider the movement along x-axis, 1-dimensional motion. If you consider in a plane, xy plane like this, we call it as 2-dimensional motion. If it is in 3 dimensions, we have to think of motion in 3 dimensions. We start our discussion with the simplest one, the 1-dimensional motion. That means we consider the body moving along a straight line like this, rectilinear motion. After understanding this rectilinear motion fairly well, then we go into the discussion of curvilinear motion. Wherever it is necessary, we will introduce the 3-dimensional motion if it happens to be necessary here in this particular schedule of our syllabus. Then, if you consider the change in position, which is what we are calling as motion, suppose there is a point here, just like what I said now. This point is on the board here. When you say the body has moved from one point to another point on the board like this, it means the board itself is not moving there. If the board is also moving along with it, then both will be differently in different position there. Like for example, you are in a vehicle. When the vehicle is moving, you are also in the vehicle and the vehicle also is moving. So there are two things moving there, yourself and the vehicle, but you are moving as one entity there. Suppose there is a big vehicle like say a train, which is stationary, and you are moving from one corner to another corner in the same compartment. Then for you, the train is at rest and you are moving there. Suppose the train also is moving now, then your motion and train motion also will be superimposed. In the present first discussion there, we consider that when you say the body is moving, we consider the body alone is moving, all the rest around it is not moving. This surroundings of the body, what we call, is stationary. It is not moving. That is our present presumption here. What happens if the surroundings also happen to move? Thus discussion comes in a different and later chapters in our module here. So this is because there is nothing absolutely at rest. Everything is moving in the nature. When you are moving, in a vehicle, suppose you see, when you are moving, you will see the stationary pole outside or a tree outside as if it is moving backwards. In fact, you are moving forward, it is stationary there with respect to the earth. So you are moving on the earth. That means earth is at rest. Another way of understanding this. When you say I am moving on the earth, means earth is at rest. That we consider for a while. I am in this room, moving from one point to another point in the room, means room is considered to be at rest, stationary. But actually the room is on the earth is not at rest, it is also moving. If you consider like that, everything is in motion in nature. Earth is moving, planets are moving, in space everything is moving. All motion is therefore is not absolute, everything is only relative with respect to the other. You will see the sun rising at the east in the morning, setting down at the west there. This is happening because of the movement of the earth, not because of the movement of the sun actually. But we say sun is rising here and sitting there, is moving from here to there, we are usually able to see. Such a motion is called relative motion. We will be discussing it in a different chapter. Here we consider, we are talking about the motion with reference to stationary surroundings, we call it. We call it a fixed frame, we call it. They are moving in a fixed frame. So the coordinate axis will fix up in that frame, and with respect to the axis of where it is moving, how it is moving, we try to locate it and try to find out. That is one point to be known. Second thing is, when a body is moving, the body may be a huge body or a small body. In all our discussions of what we are going to make here, we consider the bodies as a single entity. Even though there is a big vehicle like thing, say for example, different parts may be there at different distances from here to here. There may be some 2 meters also, 4 meters also. We consider only the entire problem as if we are representing at one point. We consider, let the body travel, locate at one point, from there onwards we go on considering it. So when say body moves from, is moving, we say from this point to that point, the entire body is located at that point as far as our problem is concerned. That is how we consider our discussions here. That is what we say point body problems, we take like that. Considering the body as a point, as if the whole body is at one point. That will simplify the problems and understanding the motion of the body as a whole. Right? Then, these 2 points to be kept in mind when we consider our discussion here. Then coming to the actual terms or physical quantities involved with the motion here. When a body is moving, what happens is, actually it will cover some distance. So it moves say from this point A to this point B, it covers a distance like this. So this is what is called distance moved, we call it. This distance moved can be different depending upon how it is moving or in which way it is moving from point A to point B. Of course it will take some time also for that. Time also will be there, it will take some time for that to go from A to B. So if it moves from here to B in a different path like that, like this suppose it is going, it is also a line, it is not a straight line, that's all. Then it is taking a longer distance between A and B to move from A to B. So this is the distance moved. The distance moved is not same like in the earlier case. So the distance between 2 points may be different, therefore it is not always the same. It depends upon which way you are moving from one point to another point there. Suppose it can be even moved in the straight line motion like that, say. Body moves in straight lines only like that, suppose. Still is a longer distance can be there. So it all depends upon how the distance is moved. That is one point to be known, that is distance moved. In whatever may be the distance it is moving, what is happening is, it is initially at t is equal to 0, say initial time it is there at A, at some t is equal to t some time, it has come to a point B. That means it has essentially shifted from A to B. So the essential achievement is this much distance only, but it has done through different paths, traveling longer distances. It could have gone along a straight line from A to B straight away and covered this distance in a shorter path, shortest path. So therefore this shortest path what we represent there with a direction from A to B straight line path, this is what we call as the displacement. Displacement is a distance, but the shortest distance between the 2 points in which the body moves along a straight line. That is what a displacement is. This displacement is a vector quantity. So first thing, when motion takes place, we have to understand distance and displacement. Distance is always increasing. That means distance between 2 points, it is, distance when a body is moving from one point to another, a distance like this, as it is moving, the distance traveled by the body is increasing. That's what I mean. Distance will not decrease there. Where will distance decrease? Suppose the body moves from one point to another point here and tries to again come back and reaches here, suppose. Now from here to here we find a shorter point available, a nearer point available here, but the distance travelled is from here to there and back from there to here. In fact, the distance could have been shorter if it had gone straight away from here to here. But it has gone like that, therefore it has taken a longer distance now. So distance is therefore, as the body travels, the distance will be increasing only. The value will be increasing. That distance is a scalar quantity, we call it. The magnitude of this scalar alone is sufficient there, which goes on increasing as the body moves. Displacement is a vector quantity. You have to take into consideration direction also, like what I was telling earlier. So when you consider like that, what happens is, when a body moves from A to B, from here in this direction, the displacement is A to B. Suppose it comes back from B to A again, the displacement now is from B to A, it is in the opposite direction. So A to B in one direction, B to A in the opposite direction, both together it is coming back to the same point again, making the displacement 0, net displacement is 0. That means this AB, as we said in vectors, BA is nothing but minus AB, reverse of that. Therefore this is 0, magnitude is the same, it has come back. So whenever a body starts from a point and covers displacements such that it comes back to original position again, displacement is 0. But distance travelled is not 0. Here actually it has travelled twice the distance. B to A, suppose it is D, then it has travelled a distance equal to 2D. D this way, D that way. So displacement is different from distance. You must understand these terms when you are working with the mechanical problems here. Then another thing. We get another example I give you for you to understand more clearly. Suppose the body is moving on circumference of a circle. It's a very standard example which you all can see easily. So body moves on the path like this, say. Starts from here, goes around, comes back to the same point. When it has come back from A, back to A only, just like what I said now, displacement is 0. How it has come to A is not very important now. It has started from A, it has taken any path, alright, it has come back to A again. Then we say displacement is 0. What about distance travelled? We consider the radius as r. The distance travelled is equal to 2 pi r, the circumference of the circle there. So distance travelled is 2 pi r. So like that we have two terms. One is a scalar and there is a vector involved here. Displacement also is the distance. Distance is not displacement. Distance is a particular distance. Is the distance shortest between the 2 points. When the displacement is 0 also, distance will not be 0. But if distance travelled is 0, displacement is 0. That means when a particle starts from here and does not move from there, it is there only. After some time t also it is there only, stationary. What displacement is that achieved? 0. And what about distance travelled? That is also 0 there. So when distance is 0, displacement will be 0. When displacement is 0, distance need not be 0, depending upon the path there. So you must remember these points before going into further ahead. So first discussion is that about displacement and distance. That contrast must be known. Then comes another word in the same way, what is called as speed. The speed of a vehicle, speed of a moving body. A car is moving with a speed, we say. What do you mean by the speed? You must have known. It is distance travelled by time taken. That is how it has been defined. You must have known in the lower class also. When we say the vehicle is moving with 30 kilometers per hour, it means it is travelling 30 kilometers in 1 hour. So many seconds. So therefore the speed of the body is equal to 30, you can simplify this, if you want to just put in words here, we can call it as meters per second, we call it. Now this is put into meters, this is put into seconds now. So the unit for the speed is meters per second. In SI we use like that. Generally sometimes we conveniently put in terms of hours also, kilometers per hour also like this. So the speed is distance by time taken. That means distance travelled in unit time. Depending upon the speed it will cover now. Suppose the body starts with 30 kilometers per hour, it will take 3000 meters in 1 hour there. That's what it means. So this is what is meant by speed. This is a scalar quantity because it is defined from or derived from distance there. So distance is a scalar quantity, therefore speed also is a scalar quantity there. Sometimes a body will be moving at different speeds. Like what happens on a road. When you start traveling there, you open the vehicle there, start going there. You will accelerate for some time, you will increase the speed for some time, decrease speed some time, go with different speeds depending upon the traffic there. So this sort of thing will say when a body is moving different speeds like that along a straight line. We consider a simple straight line condition, I told you. The speed here may be different, speed here may be different, speed here may be different. So from one point to another point, what is the speed? And it's difficult to say what is the speed. There are so many speeds there. So to put this into an even way, to put the things in a understandable way, we call it as average speed here. So average speed is the evenly put speed that is there when it is varying all through. That means when the average speed is given as total distance, if you take total distance here by total time taken. Total distance by total time taken. So this is what is meant by average speed. In this context, what happens is the body may be having a speed differently here, V1, V2, V3, you may call it as different speeds are there. And all these speeds, with each speed, it is traveling different distances. But if it were to have the whole distance traveled with the same speed, common speed throughout, then what will be the speed? Distance is d here, time taken is t, suppose. That becomes the average speed. We call it as average speed here. Should not put bar because scalar we won't put that. Average, sometimes put a bar like that. This is average speed we call. I write in words only better. Average speed. That net distance by or total distance by total time taken. Then we call it as average speed. Take the example of when you are going from Hyderabad to Warangal, suppose. You are traveling a distance about 150 kilometers there. And this 150 kilometers you are taking 2.5 hours, suppose. 2.5 hours means this 150 kilometers is total distance, total time taken is 2.5 hours. In between you are changing the gears and you are going with different speeds all through. Sometimes you will be slow, going slow, sometimes faster and so on. So then, if you call the average speed here, in this context, average speed, it becomes equal to 150 kilometers by 2.5 hours means this is 2 hours is 120 minutes and 120 and half an hour again 30, so 150 minutes. So that means 150 into 10 cubed meters by 150 into 60 seconds. So now so many meters per second. So that is the average speed what we have. So the entire thing is not covered at that rate. But because of the total time taken is 2.5 hours and total distance is this, we can take the ratio and call it the average speed there. That is what average speed means. What about instantaneous speed? At any given instant the speed will be different. That is called instantaneous speed there. Then this is easy to understand with reference to speed like this because it is scalar quantity, it only distance is involved here. Simple mathematics like that helps is alright. When you consider about the displacement involved here, then another term comes in picture, that is what is called velocity. Where direction also becomes important, not only the magnitude. Velocity is something parallel to your speed. When a body is moving with 30 kilometers per hour, simply we say it could be any direction. When you say body is moving with 30 kilometers per hour towards east, then you have made the direction clearly mentioned there. Then you have to say the body is moving towards east with 30 kilometers per hour, say. Then this 30 kilometers per hour towards east becomes velocity. You have to show it with a vector quantity with an arrow mark on the head of it. So this is what the notation we give, velocity. This velocity indicates the direction automatically in that. You have to mention that when you are telling about the problem there. The velocity is, how is this defined now? it is rate at which displacement is covered. Therefore, suppose it covered because of the velocity, displacement is covered. If you take some displacement with this velocity over for a time, for a given time, take the ratio of the displacement to time taken there, that gives you what is called velocity there. That means if it covers a distance, the displacement say x in a given time t, it becomes x by t now. So this is what is meant by the velocity. The velocity is a vector quantity because displacement is a vector quantity. Moving from one point to another point becomes important. Suppose a body moves from one point to another point, like what I was telling just now, and returns again to the same point, say. Then we said net displacement is 0. Displacement is 0. It goes plus x in this direction, minus x in the opposite direction, therefore it is 0. When displacement is 0, automatically velocity becomes 0. What about this velocity? This is what is called the velocity over the whole journey. Therefore, we are talking about average velocity. When you say a body is moving with a velocity, we are talking about that velocity. A body is moving with a velocity 30 km per hour towards east, means you are talking about one particular velocity only at that moment. That velocity may be constant throughout. That's a different question. But when you say about velocity, you are talking about one velocity only there. At one point, you are talking about it. That is what is called as instantaneous velocity. When you talk in general, like this, a body has moved with a velocity over time t taken, that means you are talking about average velocity there. When you talk about over a time, it becomes average velocity. When you talk about one point, one moment, it becomes instantaneous velocity. Our module is therefore named now as that, average velocity and instantaneous velocity. That is our module. We will now see how to understand and calculate average velocity and instantaneous velocity of moving bodies. For the purpose of this, we consider the motion along a straight line I told you. Say let us this is along x direction, and it starts from at t is equal to 0. It is started from going there. So at some point you started counting it. Say here it is x1, the x coordinate. Or sometime it becomes x2. It has come, say at t is equal to t1, t is equal to t2, suppose. Then the velocity, that means average velocity, is equal to x2 minus x1 gives you the displacement now. That is displacement. And time taken is t2 minus t1. This is what we represent as average velocity, like that. If it is along x-axis, we can put a suffix showing that it is along x-axis, putting like that, x-axis. Notations depend upon how you put it. Different books may give different suffix notations like this. One way of putting it is like this. So this is average velocity. So this average velocity over a time t2 minus t1. Suppose the body starts from at t is equal to 0, and at some point when t is equal to t, over the whole journey you want to find out the average velocity, then you will write this as average velocity is equal to, say suppose it is x0 is the displacement here. Here it is, displacement is from here to there is x, we call it. So we say it is x0 minus x by t minus 0. We can call it as simply as x0 minus x by t. So notation difference as how you note it. What is the initial point? What is the final point? What is the initial time? What is the final time? What is the difference between the two? That is what is to be put in the equation here. Net displacement by x minus x0. Final point first, then the initial point. X minus x0, you must get it here. So displacement is x minus x0. This is the displacement from here to here. So from here to here it is x. It is x0 here. Coordinate value. So put it accordingly, you will get this. Here also t2 minus t, final time minus initial time, t minus 0. So that is what the average velocity is. Then What about average speed? I told you just now. Average speed is a scalar quantity, whereas average velocity is a vector quantity. Average speed means over an entire distance we will consider that. Average displacement is taken in the case of average velocity here. But we take an example. Because generally speed and velocity are very close by terms, when we say the velocity and speed, when you consider, it appears this has magnitude and direction, this has no direction, only magnitude. Then we say the magnitude of the velocity is speed, we say. Sometimes they say like that. The magnitude of velocity is speed because in that particular case, whatever is the magnitude is containing only speed value, that's why it is called that as speed. But velocity is never speed. Speed is not velocity, they are different. When a body is moving along a straight line in a particular distance from here to there, if this is going with constant speed, then the velocity is like this along this direction, along x direction, then that Vx magnitude happens to be equal to speed. That's all. That is a special case, not every time like that. So, when you talk about average velocity and average speed, average velocity is not equal to average speed. Like with the example I gave in circle there. When a body moves from here and comes back to there, the net distance traveled is 2 pi r. So average speed is 2 pi r by t. That is average speed we call it. When it comes to average velocity, then what happens? The net displacement being 0, the average velocity is 0. So when the average velocity is 0, average speed is not equal to 0. So that contrast must be remembered. That's why we say the magnitude of average velocity is not average speed. Here see, magnitude of average velocity is 0, whereas magnitude of speed is not 0. Average speed is not 0. So therefore, that is another point to be remembered when you are working with these things. So these are the terms which is necessary to be known before going into problems at all. Then another important term is instantaneous velocity. Instantaneous velocity we call it. What is meant by instantaneous velocity? The displacement, if it is x2 to x1 in time t2 to t1, suppose, this is our velocity, what we call it, over a particular time. We can write this as, if you suppose the short displacement for a short time here, we can represent this as velocity is equal to delta x by delta t. Delta x by delta t. This is average velocity. Now if you take this delta t very small, the body is moving from here to here, for a small instant of time you are taking, this whole time is delta t. Suppose delta t tends to 0. That means you make the time as short as you can measure, smallest possible say. So it will be at one point, suppose at any point take that at this point, suppose between these 2 points you consider it here, at the smallest time, nearest point will be here. So when in the limit delta t tends to 0, this becomes equal to velocity at one point, not the whole distance. Whole velocity is not involved there. So when delta t tends to 0, that means for a shortest possible interval, the same equation will talk about instantaneous velocity at one point. That velocity at one point, one moment, is what we call as instantaneous velocity, what we said. That means we represent mathematically like this: limit delta t tending to 0, delta x by delta t. That's what we call as the instantaneous velocity, we call it velocity. We simply sometimes we say v. So when you say the velocity of a body at a point, means you are talking about instantaneous velocity. This is a vector quantity because displacement is a vector quantity anyway. So this is represented with an operation like this, dx by dt, they write like this. How do you know this value? You know it is traveling from A to B, taking a time delta t with x delta x there. How do you know what is the velocity at A itself? Instantaneous velocity at A or at any other point in between, you want to know. Then you have to make the interval at that point as small as possible. That is physically understandable. But how do you calculate it mathematically? There is a calculus method. This is how it is given. This is what is called dx by dt. This operation is what is called as dx by dt. This is called differentiation. In your calculus they call it as differentiation. In mathematics they will tell you this process very well. Differentiation means whatever the whole event available there has been cut into smaller intervals, smallest on the smallest as tending to 0, and this, which is not physically possible, has a mathematical way of putting it. We will show a small example here right now. Suppose you want to find out the instantaneous velocity at this point here. This is at a point t, from here to here it has taken time t, then it goes to small next point where time is t plus delta t, suppose. From here to here you want to find it, and velocity is from here to there, you want in between you want to find out. When delta t becomes 0, this becomes instant only, it becomes instant only now. That we will try to work out here. To give an example, suppose the body is moving here and such that this delta t, this displacement is varying with time as t cubed. So, some example is given. So the displacement is varying with t cubed time. Now that means when x is equal to t, that means delta x is equal to t plus delta t whole cubed. That is the displacement from here to there, and displacement here is minus t cubed. So this is what is meant by delta x displacement. Displacement initially is with reference to t cubed. After delta t time, it must be given by this function, because the displacement varies according to this function, t cubed. Well, so then we try to expand this. This is t cubed plus delta t cubed plus 3 delta t into t square plus 3t into delta t square minus t cubed. We expand this cube here and kept there. You can see from this t cubed gets cancelled. Then what is left over here is, when delta t tends to 0, here, that means when t is becoming 0, see what is involved here. We take the delta t out here to make it get into the formula there. We write here delta t square plus 3t square plus 3t into delta t. Now we want delta x by delta t. That is our velocity, instantaneous velocity. Definition is that when delta x tends to 0, delta t tends to 0. That is what we want to find out. Delta x is here, delta t comes down here. So what is left there in the limit now? Delta t square plus 3t square plus 3t into delta t. That is what we are left with. This limit must be when delta t tends to 0. That means put delta t is equal to 0 in the equation now. What will happen? You will miss this. This also becomes 0, this also becomes 0. You are left only with this term. So that becomes equal to 3t square. What is this? The meaning of this is mentioned in this operation. It is written like this: d by dt of x. That's what it means. dx by dt means that. That is, the displacement is differentiated with reference to time in smaller than smallest possible intervals, such that it is very small as to 0. Then you get this equation. So when x is equal to t cubed, velocity is given by this equation. Instantaneous velocity is given by this equation. This we call it as instantaneous velocity. Velocity we won't give here, we write in the direction of x. That x tells you in the direction of x here. So this is what is meant by average velocity, the instantaneous velocity. If you see this equation, I will write here for clarity again. X is a function of t, that is t cubed. Then velocity, which is dx by dt, is 3t square. That's what you got the answer now. Like that, if it is t4 here, you will get 4t cubed you will get here. Suppose it is n here, then we get as power is n, suppose, that is Vx is equal to dx by dt comes here as n t power n minus 1. This is the corresponding function is x is a function of time given by t power n. So this becomes the formula now. When x is a function of t power n, where n is an integer, so displacement is varying with the time as given in this equation here. velocity is calculated by a formula like this here. All calculus differentiation is developed like that. So function means varying with that. X is a function of time, means x varies with time, given by the equation here. So like that, any equation can be there of variation with time. There will be a corresponding formula in calculus and differentiation there. Those formulae will be given to you in calculus, and we make use of them in doing the problems here. That is what is meant by instantaneous velocity. Whenever we say the body has a velocity at a point, we need not say it is again instantaneous velocity. It is instantaneous velocity only at that point there. When you talk about average velocity, you have to say it is average velocity. The velocity over the whole journey, we call it. We will do a small example to understand this numerically. We can give any equation of x, that is displacement varying with time, given by, that means the displacement as time changes varies according to this equation. When you put t is equal to 1 second, you will show position at 1 second, 2 you will get to position at 2 seconds, 3 you get to position at 3 seconds, and so on. Now you want to find out instantaneous velocity of the body, suppose dx by dt you want to find out, say. That means, where do you want this dx by dt? Say at t is equal to some 2 seconds, say, you want that, say. You want to know what will be the instantaneous velocity after 2 seconds, that is at the instant 2 seconds there. That means, according to the formula what I said now, you differentiate this now, and given as the formula n into t power n minus 1. Here n is 2, so it is 2t minus 8, that is 1. A constant will not have any differentiation because there is no dependence of time at all there. We can only vary, and variables are differentiated. When there is something constant, you can't differentiate that. In mathematics also that is way, and here this differentiation of this will be 0, therefore you will get 0 there. So you are left with the equation, the velocity is equal to, is given by the equation 2t minus 8. Where do you want it? At 2 seconds, say, for example. That means you have to put here 2. That means 2 into 2 minus 8. That is minus 4 meters per second. This means the body is having a velocity of minus 4 meters per second along x-axis. We are talking about x-axis here. See. That means this is origin, that is the plus side of x-axis, this is minus side of x-axis. That means the body is moving from here at one point which is minus 4 meters per second. This means the body is moving along x-axis at one point. At this point when t is equal to 2 seconds, this t is equal to 0, say. At this moment the body is having velocity in this direction, opposite direction. If it is in the right direction, we call it positive direction. This is called negative direction. So when you put minus sign, it indicates it is moving towards left at that point. It may be on the positive side of the axis. This may be on the x-axis, it may be on the positive side only. It is on the positive side only here. But if it is having, it is here now, but moving in this direction, that means it is moving towards the left. If it is having positive velocity, then it will be moving in that direction. So direction of movement is different. So that means the body can be moving on the positive x-axis also with a negative velocity. Similarly, it can be moving on negative side, for example on this side. This is negative side of the x-axis. The body is moving this way, then the velocity is positive here, remember that. Velocity is positive. So instantaneous velocity, that is in the sign indicates the direction in which it is going, forward or backward. We are talking about one dimension only here. So that is what the instantaneous velocity calculation can be done like that. Another way of understanding the instantaneous velocity and velocity also, this representation or this variation of the displacement with time can be shown graphically. Even by graph you can understand that. See example I will show you here. Suppose you draw a graph like this with x coordinates on the y axis I am putting here, and x axis I will put time here. It is varying with time. Independent variable is time here. So this is origin. So with the time the body is moving different distances. Then you will have different varieties of graph can be obtained there. Suppose you get a straight line like this. With the time the body is at the same x coordinate, same coordinate throughout. That means there is no motion at all. In this case there is no motion at all. The body is stationary there, stopped. At t is equal to 0, there is some displacement called x0. At t is equal to 0, there is some x coordinate already there. x0 we call it. It may be 0 also, it may be x0 we call it. Here we call it x0, and that x0 remains constant with time. That means it is always remaining at the same position, is not moving at all further on. That is what is called this straight line interpretation. So there is no question of instantaneous velocity at all, because there is no movement at all. You take another case now. Suppose the body is moving along a straight line like that. Displacement is on the x, the x coordinate is on the y axis there, time is on the x axis as what is shown earlier. Time on the x axis and the displacement coordinate on the y axis there at constant velocity. In this case what happens? This straight line is shown here. It shows it is moving with a constant velocity. Why? What is a straight line? With a constant slope. What is slope here? If you see from here to here, this indicates delta x. From here to here it gives delta t. So it gives delta x by delta t. This delta x by delta t you take anywhere will be the same. That is where you are getting the slope as constant. Therefore the velocity is constant. Delta x by delta t is the slope tan theta, if we take it as theta. That is constant for the straight line. Therefore we call it as constant velocity. So by seeing the shape of the straight line itself, we can say it is constant velocity now. It is having constant velocity, positive velocity we can call it. Suppose it is like this. Now we say it is also constant, but slope is negative here. So we can say it is moving towards the left on negative side. So constant velocity, constant negative velocity we call it in this case. Suppose the velocity is not constant, then how do you find the curve? We will see that here. When the velocity is not constant, there can be any shape can be there. One example I give you. Suppose it is like this. It is increasing velocity. Velocity is changing, and the velocity is not constant. The velocity is changing, but displacement is increasing with time. Unlike in the case of the straight line, it is not increasing straight away at the same rate throughout. There is a different variation here. So this is not a constant velocity case. In such a case what happens? Suppose you take one point here, you take one point here, P1 we call it, P2 here. Then what will be the, if you draw a line between these two from P1 to P2, you measure the x coordinate here on P2, that gives you x2 suppose. The coordinate here is x1. So x2 minus x1, suppose is at time t, t1 here, t2 there, by t2 minus t1. This gives you velocity. What velocity is this now? From here to there, average velocity, because you are talking about net displacement only here. So this velocity is average velocity we call it. That's what we write with the symbol V, average. Now what about instantaneous velocity? At every point, at every instant the velocity is changing. That is instantaneous velocity. Now suppose you come to closer points. Suppose you bring this P1, P2 closer and closer. Say for example you want to find out instant velocity here at P1. Then what happens? Bring this point as closer as possible. What happens as you come here, it comes here. At every point when you are coming, you are making the interval shorter and shorter, T1, T2 shorter. Suppose you come to such a point here, where it becomes equal to, say from here, this delta t is very small. This delta t is very small. Then you get a straight line like this here. And the slope of this line here, this slope of the line, this is delta slope of the line you can take. That gives you delta x by delta t is nothing but the slope of the tangent there. That gives you the instantaneous velocity. That is the instantaneous velocity at the point there. At P1 we call it. Say. So like this, if you graphically also it is possible to find out the instantaneous velocity. If there is a variation of velocity taking place, at any one point you can draw a tangent, and the slope of the tangent gives you at that point the instantaneous velocity. Take another case like what we said now. When a body is taking a straight line, At any point, if you don't draw tangent, it will be the same line again. That's why it is constant slope case. It is a constant slope. X here, t here, anyway. So, if a body is traveling with constant velocity, instantaneous velocity at every point will be the same. If a body is traveling with varying velocity, then you want to find out instantaneous velocity at any point, put the graph for x and t curve, and at that point draw where you require, draw a tangent and find out the slope of the tangent there. That gives you the instantaneous velocity at that point. So it all depends upon the shape of the body can be moving with various velocities. An example can be, say, for example, say, the body may be moving like that. Say. This is displacement, this is time taken. At some point the velocity is increasing, at some point the velocity is decreasing. You can see this is positive slope, this is negative slope here. Here it is increasing velocity, here it is decreasing velocity, negative. At this point instantaneously there is a tangent like that. So the tangent here will be horizontal to the x-axis. That means at this point it is momentarily at rest. Momentarily at rest means its velocity at that point is 0 initially. At that particular point it is 0. And it is going like this. Any other point it is changing now. So like this you can find out. You can find out by drawing tangent at that point, find out the slope. That tells you whether it is positive or negative or 0, whatever the case may be. So such cases can be also known through graphs. You can attempt some problems given in your module with the graphs also you can solve them, or with the knowledge of the differentiation also they can be solved. That is what is told in this module. So essentially we have known here in this module about speeds and velocities, the contrast between them, the average velocity and the instantaneous velocity, contrast between them. Follow up the matter further in the module and get to it. Thank you.